Hello everybody. We're going to start working on Unit 2, and in Unit 2 is where we begin actually working on the content in our book. I know that some of you have already gotten a head start by using some of the archive videos I created, and that's absolutely fine, or just simply from reading the textbook. As I was just telling everybody here in class, my intent is to walk us step by step through the entire textbook. So we are going to begin with Chapter 1 and perform all the exercises in the chapter, and we are going to, be doing a lot of different things here, and there's going to be a lot of little tips and techniques and tricks and suggestions that I have for you as we work. Some of them I've already mentioned to the class here before the video even began, and I ask for their forgiveness based on the fact that I'm probably going to repeat all the same things again. But there's a few different techniques for working that are really important for coding work. One of the most important things is that you learn how to create versions of all the code that you create. So in other words, when you're working on a piece of code and you want to continue that work, you make copies of what you've already done, especially if it's working, so that if you do mess something up, you have a starting point to go back to that you know is solid. I'll demonstrate those techniques as I go. The other thing that's going to be real important is that you open up a file folder window and navigate yourself to the root of your C drive. In the root of your C drive, you'll want to create a folder like I have called Projects, or whatever you choose to call it. I think that it would be easiest for you to keep it with that particular name though, and that way we can all be on the same page. So to do that, you can just simply use the Windows tools to create a new folder. If you want to try it from the command line, you can do that too. And from time to time I will demonstrate that, so we'll see that as we work. All right, let's jump over to the book and we'll start walking through. So this is going to be a combination of both lecture and demo. And as I'm demoing stuff, keep in mind that the things that I'm demoing are actually the homework that you're working on. So follow along. If you've already done the exercises and you're kind of watching it in the aftermath, just do a fresh copy. Practice makes perfect. The more you do it, the better you get at it, and I think the deeper your understanding will get. So some of the things that we've already learned just through the process of going through the not so smooth technique of installing this software. In some cases it can be pretty smooth, and you saw the struggles I had last week, and that's not anything that should ever freak you out, right? We're delving into complicated technologies. It's okay to struggle. The struggle has its own reward, namely the fact that you know how to fix problems that will arise. And then hopefully you won't have to encounter them again. All right, we've learned already that Ruby is our base programming language, and that Rails is actually a framework for creating applications on top of Ruby. So the programming language is Ruby. Rails is what we call a framework. So keep that in mind. All right. One of the reasons that this really took off as a technology was basically the quickness and ease of deployment. So what we saw happening, especially with what we call the Web 2.0 era that kind of got ushered in, I would say right around the turn of the millennium. And, so we're actually, I think, past the Web 2.0 era at this point. But Web 2.0 was really kind of a definition that was applied to the way that the internet worked compared how it started. When the internet started out, people would create static web pages, right? You write HTML, CSS, and JavaScript. The page comes up, you look at it, you might click on things, it might even do a couple of things because there's a JavaScript that you put in there, but it really didn't have a lot of like server-side interaction, and it really wasn't interactive. It was truly static. What ushered in the Web 2.0 era in a lot of people's minds was, e-commerce, content management systems, blogging, and social media. And really the definition of Web 2.0 in a lot of people's minds is the fact that it allows for people using the web to not just be consumers of the content that you see on a web page, but to also be able to add to the content or change the content or create the content, comment on it, or interact with others who are doing the same thing. So really the collaborative type of internet that we think about when we're on Facebook or we're looking at a WordPress blog, or even if you go to a newspaper website and have commenting, that type of thing. So it's a different type of thing, and we're used to it at this point. And really that type of construct is really facilitated by the fact that the websites that you're going to truly are applications. They're not just static websites. An application, what's the definition of an application? For me, the definition of an application is the fact that there is programming code that does certain things based upon the logic you decide. And typically there will be some sort of a database or connection to some sort of a data store, whether it's a file or whatever, on the server. So to me, that is kind of some of the key things there. Now, why web-based software has become so popular, you can see that little bullet list that the guy has there, and why you guys made a really intelligent choice to be in the web program. And I'm not knocking the software program, it's a very good program, but the fact is the web is really what we call kind of our universal client, I guess is a good way to look at it, or universal platform. The web is accessible on just about every type of internet-connected device, mobile, laptop, desktop, tablet, game system, you name it, right? And so if it is easy to access, then that makes it a perfect delivery platform for applications, especially if you can get those to work. So all those bullets really apply, and that's really kind of the big part of the beauty of all this technology. All right. You guys are going to discover that some of the stuff that we work with when we're developing applications can be accelerated by choosing frameworks to help accelerate our process. Now, those of you here in the web program, most of you have gone through at least ASP.NET Level 1, right? And at some point you'll be taking .NET 2, probably in the spring or summer or whenever we offer it. And one thing that you learned when you were in that class is you can code static HTML in Visual Studio, right? And then the other thing that you learned is that you can also create project types on ASP.NET in various different formats, different back-end languages, and also different frameworks sitting on top of it. The whole reason that we have frameworks is because it accelerates the process of creating an application. We recognize that there's certain things that all web applications have in common. So the framework allows us to kind of like, okay, well, we're going to build all this stuff anyhow. Why sit there and manually do it each time? So we choose a framework, we create the project, and most of the infrastructure is already there. Then it just comes down to kind of customizing it. All right. So the author has some definitions here about what makes for a good framework. First thing is this concept of what we call full stack. And you guys probably see out in the marketplace, if you're looking for jobs, that a lot of companies are looking for full stack developers. And what the heck does full stack mean? Well, that means that everything that you need to create the application in this context, what you see, what's happening on the back end, how you create your CSS, your JavaScript, all the little components you can do through this framework. So you don't have to start using different tools to make things happen. It's all kind of in one place. It's open source. That means the source code that creates the languages and the framework are available for you to download and, more importantly, manipulate if you really wanted to customize it for your own purposes. And I know a number of different developers, there's some right here in this area that use Ruby on Rails that have done significant customization of the framework so that they can deploy their own custom content management systems with great ease. So that's one of the advantages there as well. Cross platforms, I think that's kind of a no-brainer. Works on everything, every operating system, every type of device. That's pretty crucial too. Of course, you'll always have the limitations of like the HTML technologies. We're firmly in the HTML5 era now, and just about every browser out there on any relatively modern device will support it, so we don't have to worry about that too much. You're going to see here that there's also, the author is saying, a place for everything. So in other words, they have a certain way of doing things inside of Rails that's predetermined, and we're going to work inside that framework. We'll discuss that as we go into it. Another real important feature of this framework is that we have what they call a database abstraction layer. What that means is that we have the ability to interface with the database, but instead of having to worry about typing out those SQL commands, which we could do actually in this language, they have database language shortcuts that we can employ that make our life a lot easier and make it a lot more intuitive, frankly, to code. When we first encountered the database stuff, you guys will probably be a little bit perplexed by it, but I'm hoping that as I explain and walk you through it, you'll find some really cool things about it. And mostly how simple it is to figure out how to call one thing or attach to something or pull a piece of information back without a lot of syntax. And in some cases, syntax that you can kind of switch the order of, and it still works. It's really cool. You'll see when we get there. All right. And I'm going to skip that last bullet. It's not really all that important. All right. Rails has a couple interesting features to it here as well. One thing that the author is pointing out is that database abstraction layer. Just if you want terminology to go with that, that's called active record. So that's the component that allows you to not have to write SQL to talk to that database. All right. A lot of historical background here, so if you guys want to read that, please do. But one of the things that is jumping out to me as I am glancing at that is, why do we do frameworks? Because why sit there and manually create things when you don't need to do it? Right? Are we going to go ahead and write the code to create Microsoft Word, or just pull up Microsoft Word and start using its tools? It's kind of that sort of a thing, right? Knowing how to code the program doesn't necessarily help you create the final outcome, which really is the goal of creating this stuff. So be mindful of that. All right. As a clarification, Rails, remember, a framework that sits on top of the Ruby programming language. So Ruby really is the language that we're working with, the back-end language. And it has similarities to a lot of other programming languages. So really, what's kind of interesting is a lot of the modern languages that we work with stem from the concepts that you see coming from some of the languages listed here. Now, C is a programming language that is a foundational programming language for a number of reasons. It's a language that allows you to interact with machine-level code in a little bit more of an elegant and efficient way, and actually kind of directly, compared to some other high-level languages. So it allows you to do like memory manipulation and things like that. And a lot of the languages that have followed borrow from C in its concepts, and in many cases, and Ruby and Rails is one of them, borrow directly from the libraries that are available to those languages. So when we were doing the install, one of the components was installing some of the tools that allow us to access some of the libraries that come from C and C++. So it's kind of interesting. Now, some of the other ones in this list I think are fascinating as well. You guys certainly have probably heard of C and C# if you took ASP.NET, and Java, obviously, and PHP, because we do those in the program. But there's a few here that are pretty interesting languages that some people have never heard of. And I would implore you, as students of computer science, basically, that you explore some of these. Lisp and Smalltalk are languages that a lot of students these days, and a lot of programmers for that matter, have never heard of. But I'm going to tell you that those two languages came up with some really important constructs that we use now and take for granted, and they originated with those languages. In fact, one real interesting story that I have is that my wife's uncle, he lives out in Livermore, California. He's retired now. But for a number of years, like pretty much his whole career, he was a Smalltalk programmer for one of the nuclear research labs for the U.S. government out in California. And that was the language that they used to program satellites to do communications. And from what I understand, they're still using Smalltalk to do it, which is fascinating. What's really fascinating about Smalltalk as a language is one of the things that it came up with, and I think it was the originating language for this, was the concept of what we call MVC, which stands for Model View Controller Architecture. Now, I'm not going to detail that at this point in time, but it is a development approach that allows us to take programming components and split them into small little pieces that we then stitch together to help build our application. The logic behind that is basically that if you need to make a change in one small component, why should you have to rewrite a whole bunch of stuff? You can just go to that one place and fix that one little piece and change the whole application. And so I like to point that out because it's a very powerful concept, and a lot of people learn a lot about this field and never understand the history of where it comes from. But even if you discover it retroactively, maybe you guys won't even delve into it at all, but maybe sometime down the road you can Google some of these things and hit up Wikipedia and just do a little reading. And I think it's very fascinating when you understand those. All right. Some of the other things that we want to have you be aware of is that there are websites that are official. So for example here, he's got the Ruby language org site here, and I don't know if it'll actually allow me to click the link here. And that's a website that is continuously updated. I hope it looks kind of familiar. This is where we downloaded Ruby from in the first place. But there's a lot of documentation here. There are tutorials and information, and you should not hesitate to come here to look for things if you're just curious. All right. Now, what's kind of interesting about this as well is some of the concepts that drive technology are sometimes built on concepts. So people come up with these ideas and then they try to actualize them in code. Now, as a programmer, you guys need to kind of start getting into this mindset where you realize that really the number one job of anybody in IT, right, is what, you guys? Nick, what's your number one job in IT? Blame what? Well, to keep things working and to solve problems. You guys haven't figured that out about IT. It's all problem solving, folks. Whatever you're programming, hardware, software, whatever, it's all problem solving. So there's different approaches to problem solving, especially when you're working in team environments. Now you're going to see here that he's got a section called Rails Encourages Agility. Now those of you who are also in my web project management class, which I think is almost all of you except for one, you guys should go to unit 3 or 4 in that course and read up on what Agile means. And more importantly, you should familiarize yourself with this website. So I'm going to click and open this link here. And this is a fascinating website because this is it, the whole website. All right. And this is the whole Agile Manifesto, what we see right up here on the screen. And basically, this doesn't tell you how to code. It doesn't tell you, what techniques you should use, but it does have, it's a philosophy, and it's a philosophy for creating things in a modern development environment. So I'm going to go ahead and do the cumbersome thing of reading it to you, and if you haven't read this yet or haven't been exposed to it, but it's a manifesto for Agile software development, and it begins by saying, we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value the following: individuals and interactions over processes and tools. The focus is on people. Notice that, okay? Working software over comprehensive documentation, right? Software used to come with these big, thick books. Nobody used to look at them, so why have them, right? But the software works, okay? Customer collaboration over contract negotiation. To me, that sounds like open source is better than proprietary, although you could read that a number of different ways. Collaboration really can, do a bunch of different things. So responding to change over following a plan. So you might have a plan, You got your car pointed in one direction or yourself pointing in one direction. You're going to follow that path, but then you hit a roadblock. What are you going to do? You're going to stop, or you're going to find a way around. And that's what it's all about, because development, if you guys haven't learned this yet, it's all about roadblocks. And you know what? There's more than one road that you can take to get somewhere. Some roads are faster than others. Some are bumpier. You know, you have to make that choice. But responding is important. And then finally it says, that is, while there's value in the items on the right, we value the items on the left more. So really what they're saying is we want to get things to work, and we want things to be good for people, and we want them to be realistic, and we want them, to be good. I'm not sure what else to add to that. I'll let you read the philosophy yourself. But I think that's really a pretty important little document. It comes from a very simple little website, and that's the whole of it. But that little manifesto has had a huge impact philosophically on the development world, especially in open source. And why does the author bring this up? Because Rails is built on top of that philosophy. That it's nice to be able to just type one simple command line and to create an application in one fell swoop with all the basic components in place. So, all right. Some more little concepts here. One of the principles, one of the founding principles of Rails also is what we call the dry principle. And I'm pointing out some of these things on purpose because I guarantee you they will be on the midterm and or final. So that's why I'm mentioning them now. But it's also kind of a fun thing that, if you think about it in your programming, do you really want to get yourself into the whole process of writing the same code over and over again? And this, once again, lends itself to the whole point of having a framework. Why write, a framework to do database interactions when we can just generate one? So if you're rewriting the same code over and over again, you are repeating yourself. So one of the principles here is don't repeat yourself. Find ways to make your work as efficient as possible. Right? And then the other thing is sometimes you put stuff in and sometimes you don't put stuff in. And there's another principle. You ain't going to need it. I guess that we'd call that Yagni. I don't know how you would pronounce that one. But there's some cases like we're not going to put that in because you know what? Nobody ever uses it. Now you're wondering what those things are, I'm sure. All right. Another big concept here is convention over configuration, meaning that some of the things that Rails does might be done differently in different languages and different frameworks. But you know what? That's okay. At some point, if you're working with a framework, some decision needs to be made that says, this is just the way we're going to do it. Right? You want to do it a different way? Choose a different framework. But you're working with Rails, this is how it's done. And one of the conventions, for example, in Rails is the fact that we do use MVC architecture. It's not an option. With ASP.NET, I can choose to use it or choose not to use it. In Rails, it was just considered that's just the way it's done. So instead of sitting there and having to configure or choose different options, you just go with it. All right. Those are some of the important things. Another one that I like to point out, this one probably won't be on a test, but I think it's an interesting term, is right here in the middle paragraph. I don't know if you can spot that. The author's calling this thing syntactic vinegar, right? It's the exact opposite of syntactic sugar. Well, what the heck is syntactic sugar? Let's look at the previous paragraph. It means that the syntax for something is altered to make it appear more natural, even though it behaves the same way. Now, what you're going to see here is that Rails has this capability of allowing you to type these types of commands. There were, like I told you, sometimes you can go like article.title or say title.article, and it means the same thing. Or the fact that Rails really pushes the modern convention, and this is becoming more popular in other languages too, that be really verbose with how you name things. Don't call that variable num1. Well, what the hell is that variable for? You know, it might be value of, you know, sum after calculation. So call it that. Just like that. Be verbose, call it exactly what it is. The compiler drops it all down to machine code anyways. So you're reading the code, make it easy for you to understand. All right. Now he starts to talk a little bit about the MVC pattern. Now, I'm not going to go very in-depth here on this because first I want to get us up and running, but I do want you to understand that what this basically means is that we are separating concerns. And you might hear this as a phrase as well in the book. In the old days, people would write code, and we'd get these super long code documents, right? So we'd get like one file that would have all this stuff in it, right? And it would be a mess. It really would. It would help us create what we call a spaghetti code. Yeah. And notice who they're kind of picking on here. PHP, right? And one thing you guys learned in PHP really is that the neat thing about PHP is how you can take like pages and find pieces that repeat and pull them out and make them separate PHP files and then just include them whenever you need them or require them, right? So some of that really kind of plays into the MVC pattern, but the MVC pattern actually ratchets it up a little bit. So we have a model, and the model is responsible for basically interfacing with our data. So we'll have data in a database or information in a text file or something, and we create a programming construct called a model which allows us to basically abstract that data from the database. So it's the piece that allows for database abstraction to happen. It also allows us to take the data in a database and instantiate it as an object as opposed to manipulating it directly and then writing the changes to the database in the aftermath of the changes, if we need to. The view is, well, that's, I think, pretty clear, right? It's what you see up on the screen. And then we have the controller, and the controller is where actions happen, where it's kind of like directs traffic for an application. So we're going to see that the MVC pattern relies on this technology called REST, right? Where the URLs that we create have nothing to do with the file structure of our application, like what you learned in basic HTML, where you're calling index.html, or if you go to a folder, it just pulls that up automatically. What you'll be doing is you will be building controllers that, depending on the URL typed into the browser, will trigger programming code inside of your controller, and then that controller directs the traffic inside the application to either run some programming code, pull up some data, create a view, or what have you. And it's a little uncomfortable at first when you start working in this pattern because the pieces are so separate. But it's that separation that makes it powerful and makes it flexible and really why it became so popular for doing a lot of development. All right. So what he did here is he's got a little diagram, and I'm going to bump this up a little bit so we can see it a little bit more clearly. And he says, although it comes in different flavors, and it does, flow generally works as follows. So see if this sounds like what I was just talking about. The user interacts with the interface, the browser, and triggers an event, clicking on a button, filling out a form, something like that. The controller receives the input from the interface, the submitted form data usually, and then the controller accesses the model. So the command goes to the controller, and the controller looks at the model and says, what data do I need, and does that. The controller then evokes a view that renders the updated interface, and the interface waits for it to come back, and then the cycle repeats. So a little bit different than a traditional web application. Here's a graphic of it. I'm not a big fan of this graphic, but you know, it kind of works like this. The interesting thing is I would actually draw a line that goes from the controller also over the view, because we don't always have to have an interaction with the model, with the data, but sometimes we do. Sometimes we do just generate a view. So the controller would just take us right back over to views. But most often when we're working with an application that's pulling up pages or we're editing content, we will be interacting with the data. So this is a generally correct diagram. I'm also going to tell you that there's spots in here where we're going to be throwing in like little helpers and little auxiliary code things that we create. We'll talk about those. All right. Okay, let's move on down here where they talk a little bit more about these technologies piece by piece. So, for example, the M in MVC, which stands for models, allows us to work together with the database abstraction layer and interface with components. And this isn't really necessarily the best little example here, but I think you could probably look at this code and try to figure out what this is doing. In fact, given the fact that you guys have worked with databases and applications, what would you guess this statement does? It says user, where, name, Linus, first. Guess. Yeah, and the first instance of it. Yeah, it's really, and that's the beauty of this language, is when it's all written out, you can look at it and very intelligently see what it's doing. And that's one of the powers of it. So once you have that abstraction layer in place, this is equivalent to saying select first name from table whatever where Linus, you guys know the syntax, right? So it goes on and on like that. But, that's like, 20, 30 words of code versus this real simple syntax. The controllers part is one of the more interesting things here. And remember I was telling you that we use, what Rails does is it uses what looks like clean URLs. So you'll never see like a file name attached. So you'll see like the root of a website / the name of a controller. And then controllers will actually all be in a file like this. So you have syntax. We'll talk about all the Ruby syntax when it gets down to it. But you can see like there's an index controller. So if you just land on the root of the site, what does it do? Or if I typed in or I appended to my URL /show, what would it do? And notice show, create, update, destroy, those all relate to what we call CRUD operations. And in terms of working with a database-driven application, what does CRUD mean? Create, retrieve, update, destroy, or delete. And those are what we call the basic database operations. So those are some of the things that you see built into the controllers in some cases. But the controllers are what allow our clean URLs to map themselves to specific actions, pages, data, or whatever. So that's really kind of an interesting thing. Now, the technologies that you've learned in the past, HTML, CSS, JavaScript, the key technologies, they're all part of this framework. They all work in here. So the views that we put out to the screen are still written in HTML. We can still put our CSS on it, and we can still put our JavaScript on it. In fact, you can merge it even with more languages if you really care to. Depends on the level of complexity that you want. Interesting thing about the views is that built into Rails, there are some really cool additional tools. And some of those include tools like CoffeeScript and Sass, which are like shortcut methodologies for writing JavaScript and CSS. Very modern techniques that are really good to know, and they're used in frameworks other than Rails. So they're kind of neat. All right. Shoes too. The other thing that I want to point out, as the author does here, is the fact that there are some libraries that are built in. So we start to work with Active Record, Action View, and Action Controller. These are specific libraries that are pre-built and added to our applications that allow for specific functionality, as is indicated here. We will explore those as we proceed. When you're working with Rails, one of the points here with the modular part of it is that in some cases you'll need some libraries, in some cases you'll need others, And if you've worked in Visual Studio with ASP.NET, you know what I'm talking about. Like sometimes we pull in certain tools as we need them. Rails has that capability as well. All right, so I think that covers this chapter as much detail as I'd like to put in it. So I'm going to end this video here and I'm going to start a new one. But hopefully that gives you a little bit of a background about the technology that we're working with and the power that goes with it. All right, this video ends here.